All right, everyone, we're on. We're on and we are starting. I'm going to do a screen share. So now my screen is shared and I'm sending my last messages to everyone who can join. Okay, turning off my phone and we're starting. So you see that there is nothing here in the window that says Gotham Math. So I'm going to put here the calculator most likely, and on the stream on YouTube we actually do have a video running, so it's all good. All right, so starting our stream, we are finally got to get to the problems of Algebra 1 Regents January 2025. That's the latest one. And the most recent one, right? So by the most recent test, we can see like what's kind of, not even what kind of questions are coming, because we know what kind of topics, like topics don't change, but maybe intensity, the hardness, maybe some new types of, I don't know, some tricks, maybe, I don't know. It's the best way to prepare for the upcoming test, to see what was the most recent one. So that's exactly what we're gonna do now. That's why it's an important stream today. Now, if you have any questions on the side, you can always do what? You can always ask me in the chat. So I don't know if you see it over here, but there's a chat, and you can always do a private message to me, not to everyone. You can switch it to like only me, and I'll try to answer that. So let's get going. We most likely won't be able to do everything. I hope we can do. We won't be able even to do a half today. It's most likely going to be split in 3, maybe even 4 parts. Why? Well, because I'm going to break down every single problem in like a smallest detail, so that there is no way you kind of did not get the answer, or did not get the idea. So let's see. Now we're starting from question number 1. When factored, the expression this is equivalent to. So, by the way, guys, I never read the expressions. I try not to. It's just we see it, we recognize what it says, and why do we actually have to say x to the third power minus 36x? It's just a waste of time. Plus, well, this one is not that long, but they get longer. So, all right, so we want to factor, and as soon as I see this binomial, which means two things, x to the third, 36x, I see that they both have x. So this is my first, something that I noticed first, that they both have x, and it means that I can factor out their x right away, like right now. So how it's going to look like, the x will go outside, and inside I'm going to have 1 less x on the x to the third, which is x squared now, minus, and then we take that x out from 36 and we get 36x, and we get 36. Now we get x times x squared minus 36, and x squared minus 36 is a specific formula that's called difference of two perfect squares and difference of two perfect squares formula goes like this: a squared minus b squared equals to a plus b times a minus b. So we're going to break x squared minus 36 as x squared minus 6 squared, which will equal to x plus 6 times x minus 6. The chances that the question with the difference of two perfect squares formula will come on the test is 100%. Not only on the algebra one it comes, it actually comes on many tests, even maybe even sometimes on algebra 2 tests, or on even on the SAT test it comes up. So having said that, this is the full breakdown, right? We're moving on. This is question number 1. Shouldn't take that long. All right. So which equation, number 2, which equation represents the line that passes through the points -1, 8 and 4, -2? It's just a classic type of question. Something that if you're actually studying algebra 2 properly, that comes up all the time. Creating an equation from two different points. If you don't know how to do it, most likely next time you see me on any of your like live classes with me, I think that you should just like let me know, hey Roman, I don't know how to do this. I will assign some delta math practice, and by doing delta math, you'll probably remember and learn how to do it. So let's go. It consists of 2 steps, 2.5. Step 1 is slope, finding slope, and step 2 is finding b, and step 3 plugging in the answers that you found in step 1 and 2. So step 1, the slope, is found by the slope formula. y2 minus y1, x2 minus x1. So these are x and y. 1, 1, 2, 2, which is -2 minus 8 over 4 minus 1, which is -10 over 4 minus -2 is 4 plus 4 minus -1 is 4 plus 1, which is 5, which comes down to be -2. If you do know that all of them are in y equals mx plus b form, and you should know that, then we just found this. We just found m. And right away, we can see that there are only 2 answers, here and here, have -2 for the slope. So 3 and 4 are wrong. Now we have to find the b. Now we have to find what is that last number there. How are we going to do it? We're going to plug in into y equals mx plus b, one of these points that we have, which one of the points. So let's say I'm going to plug in, you know what, I'm going to use a different color. I don't know, pink. Okay, so -1. So one of our points is -1, 8. I'm going to plug in into y equals mx plus b. And I'm also going to plug in the slope that I found in step 1. So what's going to happen? This is x and this is y. So this comes here, that comes there, and then b will stay as a b. So it's going to be 8 equals to -2 times -1 plus b. 8 equals to 2 plus b. Subtract 2 on both sides. I get 6 equals b. This is it. Technically, you don't need to do the third step because you just found the b and you see that it's 6. Do you really have to do the third step? No, you don't. Maybe if it would be a short response question, yes, you do. But right now, no. Just select number 1 and move on. Don't waste time. All right. We're moving on, and let's see what we got. Oh, this is just number 3 is, we're not even gonna like spend that much time on. Like they say, what is the common ratio of this sequence? 1/2 to the 2, but then you kind of can see that it's 2 to the 8, which is times 4, and 8 times 4 is 32, so it's just 4. It's just numbers being multiplied by 4. This is kind of like thank you very much type of question. All right, so we're moving on. Number 4. What is the constant term of the polynomial? Constant term. Constant term. Term without a variable. What does that mean? Just a number without x. That's what it means in this case, because the variables are x's. So just a lone standing number. 5. That's all. That's all. It's just a theory. Just remember that. Just theory. Moving on. A landscaping company charges a set fee for a spring cleanup plus the hourly labor rate. The total cost is modeled by the function c of x equals to 55x plus 80. In this function, what does the 55 represent? So again, if you do enough of preparation, and since we're already kind of all here already, and hopefully we're just going to be doing this more, you will just start seeing more of these type of questions. When they give you a y equals mx plus b type of question, like I would say an equation, and ask what's what. Well, let me tell you what it is. So, and how it actually breaks down all the time. You know what? Since I don't want to put it like on top of these words, so let me do it separately. C of x equals to, okay, so I'll do it here on the side. C of x equals to 55x plus 80. So what's everything is? Whatever this is, c of x, f of x, I don't know, g of x, doesn't really matter. It's just a name. It's just a name c, cx. So function c, that's kind of. So it's usually the total. Total on the money, total, I don't know, total of wherever. This is usually the total. The total money earned, the total, I don't know, minutes passed. I don't know idea. Like you just need to know that that's some sort of a total. Now, what is this number? This number is usually a set fee. Something that doesn't change no matter like how many hours you've rented the boat or the car or whatever. You're paying like a set fee to get in, and then it's like, and then it becomes hourly rate. So it's a set fee all the time. And now finally, the number I would say, so we can split it between 55 and x, right? But technically here is something that's like a amount that changes, I would say. What do I mean by that? It's like if X is the amount of hours someone works, then if it's 1, then you pay them $55. If it's 2 hours, you pay them $110. If it's 3 hours, so it's something that changes, like an hourly rate, or like something that you have to pay more of, like the greater the X will be, the more you will have to pay. Like the greater this number will go. That's how it works all the time. I'm breaking this in such a small detail because it always goes like this. So if you remember this situation, this setup, it will, like, no matter what type of words they're gonna put in the problem, cars, I don't know, like hourly, I don't know, plumbers, hourly rate, landscaper, it doesn't matter. They just change the story, but the idea is always the same. So what does the 55 represent? So it's how much this landscaper or landscaping company charges hourly. This is what it is. Hourly labor rate for a cleanup. Boom. Set fee is the 80. The profit earned by the company is the total, right? And this, like the number of hours required, is actually X itself. This is the amount of hours. So this is what it is. This is how this problem works. All right, we're moving on to number 6. So far we're going with like pretty good speed. All right. This, just like with the y equals mx plus b and 2 points, this comes up often. You can see it. And like I said, if you don't know how to do this, ask me to give it to you over the delta math, and this is kind of going to be guaranteed points for you on the regions. Guaranteed. So what is the trick here? The trick here is this minus. Like, people don't know. You know what people do sometimes? They just write minus 3x squared, and then they keep this plus, and then they keep this minus 1. That's what people do. But it's wrong. What you have to do is to apply that minus onto every single number that's in there. Or in other words, just change every sign inside of the second parenthesis. That's what it technically is. So what's going to happen is that it's going to be 5x squared. The first parenthesis you almost always copy. Minus 2x plus 4. Then minus applied on the 3x squared is negative 3x squared. Minus applied on the 3x is minus 3x. And minus applied on the negative 1 is plus 1. 5x squared, and then you combine like terms, obviously. So 5x squared and negative 3x squared is 2x squared. Negative 2x and negative 3x is negative 5x. And positive 4 and positive 1 is plus 5. That's it. That's all we need to know how to do. The answer is 2. Again, if you haven't done it, you need to learn it as soon as you can and practice as soon as you can. Moving on. Number 7. Number 7 is an interesting question because it looks hard. Usually this topic comes up on the short response questions, but it's actually a pretty easy question. So it says, which point is the solution to the system 1, 1? So it's 1, 1, So solution of the system are the points where the double shading is happening. And the double shading is happening in this region. If you see that the dashed line has, you know what, I'll do it with different colors. The dashed line solutions come from like from the to the right from it, like this. Now the solutions of the solid line comes to the right from the solid line. So officially the answer set, the solution set, is where those two intersect. So it means that we have to choose any number, or like the number that's given to us from this region. Basically, like in this way, for this particular picture over here. And when you're gonna go through all of them, you'll see that only one of them will make sense, which is 4, 2. Look at this. 1, 2, 3, 4, 1, 2. Boom. It's here. It's definitely inside of this. And that's the answer. This is it. All right, moving on. Well, finally we're getting something that is interesting. This question is about arithmetic sequence. In arithmetic sequence, the first term is 25 and the third term is 15. What is the 10th term in this sequence? So what do you do and how you solve questions like that? It goes like this. You have to find what is the common. So first of all, you see the words arithmetic sequence. So what do? You have to go like on, you're gonna have like a whole region packet, right? So you have to like go to the last, not the last page, second to the last page, and find the words arithmetic sequence. Here it is. And copy this formula into your problem. You don't have to do it, but you kind of like want to do it, you know? So you want to have it in front of you. Okay? So you go back and you write it down. AN equals to A1 plus D times N minus 1. So I think that you need to know what everything is here. I don't know if there's any better way to actually explain this rather than just telling you what everything is. So AN is the number that's usually is asked in the problem, like what is 15th, or what is like 30th term of the sequence. So requested term of a sequence, you can say that this is what it is, term in a sequence. Sorry about that. Now A1 is first term. First term is given to you here, first term, 25. Now, what is D? D is what's called common difference. What is common difference? Like in the numbers like 2, 5, 8, 11, the common difference is 3. Right? This is what common difference is. The jump from one number to the next number. So this is common difference. And N is the number in the sequence. Which one they wanted? Like 30th, you have to put 30. Like 20th, you have to put 20. And you just fill it in. The only thing is that, hold on, the only thing, you can't fill it in yet because you don't know common difference and you have to know how to find it. How do you find common difference here? You find common difference by subtracting like basically one of the terms that you have, like third term, right? So let's say we have first term. I'm gonna put it, I don't know, here on top, on the left top. So the first term is 25. Third term is 15. How do you get the common difference? You subtract third term, like, and it doesn't matter if it's fifth term, you still subtract minus the first term. You get 15 minus 25. You can do it on a calculator. It will be negative 10. And then you divide it by subtracting 3 minus 1. Actually, it's kind of like doing slope, to be honest. y2 minus y1 over x2 minus x1. You know, 3 minus 1, 3 minus 1, which is negative 10 over 2, which is negative 5. Now we know what D is. And now we have everything we need to find the answer. Let's do it. Let's do it. It's going to be AN. Actually, they say 9's term. So A9. 9's term they're looking for. You don't have to put it. It's just I'm showing you how it's like technically looks. First term, so which is 25 plus common difference, we just found it, it's negative 5, so technically then minus 5. Minus 5. It's plus negative 5, but I don't like putting two signs in a row. Times n, which is number in a sequence, we're looking for the 9th one, right? So it's going to be 9 minus 1. And by doing this, you will get your answer. So 9 minus 1 is 8. Negative 5 times 8 is negative 40. So it's 25 minus 40, which is negative 15. I'm sorry, hold on. 40? Did I miss something? 9s. Should be... To be honest, I'm not really sure where is the 9 minus 1. 9. Oh my god. Why do I say 9s? That's crazy. When it says 10s. Where do I get 9 from? Ooh. That would be embarrassing on the video. Why did I write it like no. Okay. It's 8 p.m. Maybe. You know what? Maybe my brain is kind of calculated already, like 10 minus 1, which is 9, right? But it's tenths, right? Tenths term. Like we're looking for tenths term. So 10 minus 1. Yeah, which is 9. So we have 25 minus, and then 10 minus 1 is 9, and negative 5 times 9 is 45, which is negative 20. 25 minus 45, negative 20, and that's the answer. Okay, quick highlight recap is we have formula. Like, first of all, we see arithmetic sequence. We go for the formula. We got the formula. We need to know what every single part of this formula is. We found the common difference. We plugged it in, everything, common difference, and like the n, which is 10, right? We calculated, we got the answer. This is it. Is it more or less hard? Yeah, I would say harder than what we just did, you know, just like finding where the point is or whatever, you know. It's maybe in this sense it may have been harder. All right, guys, next question. Next question is this. When the formula P equals 2L plus 2W is solved for W, the result is. All right, so this is just solving for a variable. It's called lateral equations. When you don't look for the answer, you look to like reshape it. That's what you're doing. You're reshaping this. It's going to be still the same algebraically. It's going to be the same thing, but you're changing in shape, like those little like I don't know, like it's like you know those toys that's like you can change the shape of, like from one to another, like they're popular right now. Some kids have it. This is what it is. So how do we do it for W? First, we take the 2L and we move it to the left side with changing sign. I don't want to say subtract because in this case, moving it's I don't know, seems kind of like easier to understand. So it's going to be P and then minus 2L equals 2W. And now one more move left is just to divide by 2. This is it, guys. This is not that hard. It's just two-step thing. They're literally trying to check whether you know that you know how to move this, and that in order to get rid of the 2 in front of the W, you have to divide by 2. This is it. This is the answer. P minus 2L over 2. That's all. Comes up a lot, though. Algebra 1 and SAT. Algebra 1 and SAT. All right. Next, number 10. We're already at number 10. Okay. Let's see. Market Street Pizza kept a record of pizza sales in the month of February. The results are shown on the table below. Of the pizza, so now we have to find the probability. You see, so of the pizzas sold in February, okay, so that's all of them pretty much. What percent were plain? Because they say all of all pizzas, all everything. So we have to probably add every single number here. So probability, what percent were plain deep dish pizzas? Plain deep dish. So we'll look for plain. This is plain. We'll look for deep dish. That's this. So where do those intersect? They intersect at 200. So it's going to be 200 over something. Over what? Over everything. Over all pizzas. So let's just add everything. I'm going to add up like this. I'm going to add up like this way. You know, like lines in the line. So it's going to be 200 plus 25 plus 105. That's going to be 200, and then 330 plus 7 is 400. And on the top we have 300 plus 80 plus 120. That's 500 plus 100, 600. So the total will be 1,000. So it's going to be 200 over 1,000, which is, well, I hope you understand what percentage it is. You know, if we divide it by 10, it's going to be 20 over 100, which is 20%. And that's it. That's it. The table, the percentages, everything looks harder than it actually is. In reality, it's actually not that hard. All right. Equations. Ugh. Equations. You know, I'm not even reading the words. Like, when solving this for x, the solution is. Who needs to read this if we understand that we need to solve for x? that's the only thing that we need to know. For x. And it's just a technicality, a technical skill that you need to have. And, you know, this is one of the skills that I think that just for the development of yourself, you need to know how to do. You know, it's math after all. All right, let's go. Distributive property. First, negative 2 times 3x, negative 6x. Negative 2 times negative 5 plus 10 equals to 9 over 2x minus 2. What do I do now? Well, I can do plus 2 on both sides. I get negative 6x plus 12 equals to 9 over 2x. What do I do now? I'm going to add 6x to both sides. It's going to be 12 equals 2 and 9 over 2 plus 6. On the side here, I'm going to do 9 over 2 plus 6 over 1, which is, I can multiply by 2 top and the bottom, and I have 9 over 2 plus 12 over 2, which is 21 over 2. So it's going to be 12 equals to 21 over 2x. And the rule of getting rid of a fraction as a last step, dividing by a fraction, is the same as multiplying both sides by the reciprocal of it, which is times 2 over 21 on both sides, which is cancels that fraction in front of the x, leaving you with just x. And on the other side, we have to multiply. Yeah, it's going to be 2 over 21 times 12, which is going to be 24 over 21. If we don't have that, and we don't, because it's actually unsimplified, we simplify it by reducing it by 3, which gives us 8 over 7. And that's already here, because it's 1. I'm not even going to recap this because, like I said, technical skill and nothing much here. Just be focused. Don't miss on the signs. Do the math on the side and try to stay clean when you do this, and you're gonna do fine. All right. We're on question number 12, and 12 actually looks hard. It looks not hard, like intimidating, I would say. The expression x to the power 2a plus b is equivalent to, okay. I have x to the power something plus something. And this is a rule you need to know. And let me show you the rule which will make, which will probably make you answer that question on your own. Like, I'll answer, but which will make it easier for, like, in your mind. So when we have x, let's say to the power 3 plus x to the power 5, not plus, times. We can write times like this, but we're going to use a dot. That's times, because you cannot really write a little cross here. It's going to look like XXX. So we have to use a dot. That means multiplication. What we do, we add the powers. Okay? Which is eventually x to the 8th, right? But what if I would have like a number and a letter for x? Like, let's say x to the 4th times x to the y, let's say. How that will look like? I would have to write x. I cannot add 4 and y. It's just going to look like 4 plus y. Well, this idea you have to just see over here. It's going to be so when we multiply, we add powers, right? So the correct answer will be, well, it can be nothing but the answer 3. Why it's the answer 3? Because it's multiplying x's, and what we do when we multiply x's, we add powers. So technically this will be x to the power a plus b, right? This a and this a plus b. And a and plus a plus b is going to be 2a plus b, because a plus a is 2a, and that's it. That's the answer. This rule is being used over here, this particular one. Okay, this is how it works. It's called exponent rules. Also can be given on the delta math. All right, I think we're just gonna go until question number I don't know, we'll see. We'll see. Maybe like 2 more. Maybe we'll finish on this page. All right. Now, the inputs and outputs of a function shown on the table. The function can be best described as, all right, linear, quadratic, exponential, absolute value. All right. Let's look at them. Well, x goes just 0, 1, 2, 3, 4, 5. What about fx? This number, then this, then this, then this, then this, then this. So 2, and then 1, and then 1, and half of 1 is 0.5, and half of 0.5 is 0.25. So this is kind of like, technically, it's kind of like times 2. This times 2 is this times 2 is that, and so on. So when we have a consistent multiplication in the difference of the output, the function is called exponential. If it would be plus something, like plus 2, plus 2, plus 2, plus 2, plus 2, it's going to be linear. Quadratic is going to go up, like let's say actually down and then up. Like it's going to be like -2, -3, -2, -1, 0, and then 2, 3, 1, like 1, 2, 3. You know, like it's gonna go down and up, or like up and down. But here it's just consistently going up times 2. Absolute value same as quadratic, but like that. Basically, I would say same. It will look very similar, you know. So, exponential. Number 14. Stephanie is solving the equation x squared minus 12 equals 7x minus 8. Her first step is shown below. So what is her first step? Her first step was... Okay, so it was a -8 here. Now there is none. She added it to the right side like this. She did +8 +8, and that's why she got -4, because -12 + 8 is -4. What kind of property is this? Distributive? Nuh-uh. Okay, associative? Don't think so. Now, commutative, or addition property of equality. Well, commutative property is when you move one thing from one side to the other. So the correct answer here will be addition property of equality. We add 8 to both sides. That's why it's that property. All right. Moving on, and I think that's gonna be the last question of the day, and then but don't leave just yet. I'm gonna tell you the plan on how it's gonna go, and we'll be done. So number 15, what is the sum of 8 square root of 3 and square root of 3? You know, I actually did this with someone recently, and they asked me, like, how do we know? So there are 2 things you can do. As a backup plan, you can do it on a calculator. Actually calculate what is square root of 3 times 8 and what is just square root of 3, then add them and then look which one is which answer will be the same, which give you the same result. But Uh, I'll show you something that's will like that I've noticed myself. I don't know if it's being taught like that, but I've noticed that radicals behave just like x. Like let's say this behaves just like this is 8 and this is x, like 8x. What is 8x plus and x? It's 9x, right? The same way radicals behave. It's 9 square root of 3. Because the square root of 3 doesn't have a number in front. And when x doesn't have a number in front, we consider 1. And so we do over here. The same works for subtraction, like let's say, so the answer is 9 square root of 3, right? So it's 4. But like it's the same works for subtraction, like 7 square root of 2 minus 5 square root of 2 is the same as like 7x minus 5x, which is like 2 square root of 2. And what's interesting is that it goes even further. It goes even further. Like it actually very similar to this, but even more similar to this. But you don't need to maybe get into that much of a detail for this right now. But soon you will, and we'll see. We'll see. Like I'll show you more. For now, just remember that. That's how you add them. All right, so we're gonna stop at question number 15. Now, what I wanted to say is that during our next class, I'm going to continue from number 15. That means that I'm not going to do this Regents test with anyone before doing it here. And that's how we're gonna go about it. Every single question is going to be literally like demolished, just like I did today. Every single one. Now, this live video is going to be saved automatically on my YouTube channel for the future reference. If you would ever want to be like, hey, how did he solve that question, or how he solved that question, you'll always be able to go there and watch and rewatch. And right before the Regents, I think we're gonna have to you're gonna have to do it like maybe like once or twice. But for now, this is it. I will see you all during your own private classes, and that will be it for today. So everyone have a good night.